Okay, today we're going to be going over 8.2 on trig ratios in a right triangle. Our learning target is I can find the sine, cosine, or tangent of an angle in a right triangle by making ratios with the correct sides or using a calculator. I can use a trig equation to find a missing side in a right triangle. Okay, our pathway connection is to architecture. It says an architect uses trigonometry in their blueprints because it's important to know if the structure is going to be stable as well as structurally functional. Many buildings have unique architecture, therefore it's nearly impossible to confirm that it will be structurally sound without using trigonometry. Okay, so trigonometry is going to be used in all these blueprints because even though there's tons of shapes going on in this house or picture, we can find triangles all over the place. And if we use trig, we can make sure that they're built solid and they're not going to collapse. Okay. So before we get going on the trig, we're going to do just a quick little review on the Pythagorean theorem. Okay. Pythagorean theorem is a squared plus b squared equals c squared. Remember, c is always the hypotenuse. Okay. So looking at example A, I know that my hypotenuse is always straight across from my 90-degree angle, or it's always the longest side. So I can say that 10 is my C in this case. Now, when it comes to the legs, it doesn't matter which one you label A and which one you label B. So I can say that 7 is going to be A in this case. Now that I have two of my sides, I can use the Pythagorean theorem to solve for the last one. So I can say A squared, or 7 squared, plus B squared, and I don't know what B is, so I'm going to leave it as B squared. That's equal to C squared, which in this case is 10 squared. Now, to get this all by itself, to get B all by itself, I'm going to subtract 7 squared to both sides. It's going to leave me with B squared is equal to 10 squared minus 7 squared. And then my last step to get B all by itself is to square root both sides. So I'll have B is equal to the square root of 10 squared minus 7 squared. If I put that into my calculator, I'm going to figure out what B is, or if I don't have a calculator, I can just do the math by hand. Either way, you're going to find that your answer is going to be the square root of 51. Okay? Now take a second to try to do this on letter C. We're going to skip B. Try to do this on C. You should end up with 3 square roots of 3 as your answer. Okay. Now we're going to talk about trigonometry. Trigonometry is the study of triangle measurements. Specifically, we are studying the ratios between the sides in a right triangle related to a particular angles. These are called trig ratios. Okay, so what we're going to be doing today is these 3 steps here. We're going to identify the angle we're using. Okay, the angle we use is always identified by one of these little angle marks or this little symbol right here. That symbol is called theta. Okay. So if you have this little angle marking or theta, that's the angle we're going to be using. Then step 2, we have to label the sides in relationship to that angle. Okay. So the first and the easiest side to label is always the hypotenuse. Okay. The hypotenuse is always straight across from the 90-degree angle, or it's the longest length. Okay. So that would be our hypotenuse. Then the second easiest side to always label is the adjacent, because the adjacent is always touching our angle. And if we've already labeled our hypotenuse, that means that the adjacent has to be this one. Adjacent means next to, so the adjacent is touching this angle right here. And that leaves the last side to be my opposite. Okay, so hypotenuse is the easiest, it never moves, but the adjacent and the hypotenuse can switch depending on which angle you're choosing. If you do this angle or this bottom angle, they'll switch places. But remember, adjacent's always touching your angle, and opposite doesn't touch your angle. Okay? Then once we have our triangle sides labeled, we just make ratios using those side lengths. So there's 3 trig functions that were talked about in the objective. Those are sine, cosine, and tangent. Okay? So sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? Now there is a quick little acronym that helps us remember this, and that's SOHCAHTOA, as written right here. That means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, just like these trig ratios over here. This is the way I learned it when I was in school, but there is a new way that they write this out now. And it's still SOHCAHTOA, but it's written like this. SOHCAHTOA. And these mean the same thing, whether you like writing it like this or like this. This way is just a little easier to see the fractions or the ratios that we're going to make. Okay? So, let's do a couple of examples here. In D, it says express the tangent of L as a fraction in simplest terms. Okay, so step 1, identify my angle. It wants L to be the angle I talk about. So that's this angle down here. That's the angle I'm talking about. Now step 2, I need to label all my sides. Okay? The hypotenuse is always the easiest one because it's always straight across from the 90-degree angle. That means this is my hypotenuse. Okay, the adjacent is the second easiest one because it's always touching my angle, which means 36 is the adjacent. That leaves my last side, 27, to be my opposite. Okay? Now I need to decide which one of these trig functions I'm going to be using. Okay, it wants the tangent of L, which means I'm going to be using the tangent function, or this one right here. Tangent is opposite over adjacent, opposite over adjacent. So if I know I'm using tangent, then I can say that my ratio is my opposite, which I labeled as 27, 27 over my adjacent, which I labeled as 36. Now we can simplify this to 3 over 4, and that is our final answer there. Okay? That's all we're doing today. We're making these ratios. We have to label our triangle and then make these fractions or ratios. Okay? Looking at example E, it says it wants the sine of O. So O is the angle I'm going to use. So I'm going to do this angle down here, angle O. I need to label my sides. Hypotenuse is the easiest one to label. I'll label that one first. Then the adjacent's the second easiest because it's always touching this angle. And then that leaves 7 to be my opposite. Okay, now I need to decide which one of the 3 functions I use. It says sine of O, so that means I use sine. Sine is opposite over hypotenuse. Okay, so I need my opposite, which I labeled as 7, over my hypotenuse, which I labeled as 12. 7/12. That one doesn't simplify, so that's my answer right there, 7/12. Okay, looking at F, it says find the value for the cosine of K. All right, well, we're looking at angle K. Angle K is this right here. Now I need to step 2, label my sides. The hypotenuse is always straight across from the 90-degree angle. The adjacent is always touching this angle. and that leaves 4 to be my opposite. Now, step 3, make the ratio. I'm using cosine, and if we look up at the top of our paper, cosine is adjacent over hypotenuse. So that means we use our adjacent, which we labeled as 3, and put that over our hypotenuse, which we labeled as 5, 3 over 5. But this says we want to round our answer to the nearest hundredth. So if I put that in my calculator to round it, I get 0.6 as my answer. Okay, we'll do one more together. It says G, express the cosine of K as a fraction in simplest terms. So we're going to use K as our angle. And then we got to label our sides. Our hypotenuse is the first one I'll label. Our adjacent is always touching this angle. So this is our adjacent. That leaves 9 to be our opposite. I'm using the cosine of K. So cosine is adjacent over hypotenuse, which means the ratio I need here is my adjacent over my hypotenuse, but I'm not given my adjacent. So I need to use Pythagorean theorem to find my missing side. The way we practiced it at the beginning. But I know my hypotenuse is 15, so I can do that quickly by saying, okay, well, I know that my missing side or my adjacent side is going to be equal to the square root of 15 squared minus 9 squared. That comes straight from the Pythagorean theorem. Okay, so if you're missing a side length, use the Pythagorean theorem to find your missing side length. After doing the Pythagorean theorem, we end up with the adjacent side is equal to 12. So I can label this as 12. Now I can come in and say, okay, my adjacent is what I need, 12 over my hypotenuse, which I labeled as 15. 12 over 15 simplifies to 4 over 5, and that would be my final answer. Okay, now we're going to skip H and I, and J and K are going to be partner practice. So complete these, and then come get it checked off and get a stamp when you're done.